Our next question is, consider a water tank shown in the figure. It has one wall at x is equal to L and can be taken to be very wide in the z direction. So in this direction, when filled with liquid of surface tension S and density rho, the liquid surface makes angle theta naught with the x axis at x is equal to L as shown in the figure. If y of x is the height of the surface, then the equation for y of x is, so we need to find equation for y of x, but the expressions that are given are double order equations and single order equations, differential equations. So we should work on it and get the differential equation. So here this is the liquid, so which is having some meniscus at the end of a wall. So in our NCERT textbook, so we have a capillary rise concept. There if you pour some water inside, it will take the rise like this. A spherical shaped height formation will be there in it. So there if you take the tangent here, this angle is called meniscus angle. Okay, this angle is meniscus angle, but when compared to with this, so that is not the given thing. They are given this thing theta naught. The meniscus line is making angle with the horizontal, but here this meniscus angle is making with vertical. So if you extend the lines, this is theta naught and this is the actual consideration of meniscus angle, which will be 90 minus theta naught. Okay, so there the formula is given for the change in pressures at the edges, delta P is equal to 2s by r, where r is the radius of that spherical surface, and further it is termed with a secant theta, where a is the radius of this test tube. Okay, radius of this test tube, that means it's a horizontal distance from the wall. It's a horizontal distance that is impacting on it, impacting at half of that one. So 2s by a secant theta, if you consider the whole length, it will be 2a secant theta. So then 2 gets cancelled. We are considering only 1, so even for the given question also it is half only. So it will become, so delta P will become s by a secant theta. In our case, a will be considered as x only because it's a function of x, so which is equal to s by x secant. In terms of theta, I can write 90 minus theta naught. So I will reshuffle this formula. Delta P by s into x is equal to, this is, if it goes up, it will be cos theta, cos 90 minus theta. So that will be your sin theta naught. But according to the given situation, that theta naught or angle is the expression of x and it is very small. Now you can consider dy by dx for that. Sin theta naught is theta naught and that will be dy by dx, where that length, when you go forward, your y is increasing, your x is also increasing. Like if you increase your x, your y is also increasing. So that the rate we are considering dy by dx. That angle is depending upon that rate dy by dx. So this is the formula. So dy by dx is equal to delta P by s into x. So if you see these expressions, the first one and fourth one are not representing that at all. So let it be. Now for the other two options, we need to take a double differentiation. So take the double differentiation with respect to x. You will have d square y by dx square is equal to delta P by s into dx by dx. So that is the answer. But what is delta P? Change in pressure. Delta P is equal to rho z. Height we need to consider. In here height is y. So y divided by s. So the answer would be third one, rho g y by s. So answer would be third one according to this expression. No need of purely calculus based explanation. So it is already given in the textbook. This expression is given in the textbook at the meniscus concept. So from there we can resolve this thing.